guys, I am ready for the last lesson of Module 14, Lesson 3, on page 393. So go ahead and get your math book and a pencil and follow along with me. So the title of this lesson is called Use Unit Fractions to Describe Area. So this lesson is going to sound very familiar to the unit fractions lesson that we had in Module 13. And really, the takeaway, I think, from this lesson is that fractions represent something. I really want you guys to have that understanding that fractions aren't just this abstract thing. It's not a random number. It is a representation of a part of a whole circle, a whole square. So they represent something and they have meaning. So that's the biggest takeaway. We're going to practice and go through this lesson, and then we'll be done with this module. So our I can statement, the blue bubble, it says, I can write a unit fraction to represent the area of each equal part of a whole shape. So we know what unit fractions are. Unit fractions tell us what each part represents. So basically it's the value of one part. So let's go ahead and do the Spark Your Learning. It says, Rex plans to divide the hexagonal shaped pool into 6 equal parts and paint one part green. What unit fraction of the pool should Rex paint? So what I'm looking for is to find what unit fraction of the pool should Rex paint. This is a cool looking pool. It looks like a hexagon. That is pretty neat. All right, anyways, it says show how Rex should divide the pool. Name the unit fraction of the pool that he should paint. Explain your thinking. So he is going to paint one part green, and we're dividing this pool into 6 equal parts. So I'm looking at this hexagon. Anytime we're dealing with hexagons, octagons, circles, anything that is a bit round, I want to really focus on that center and make sure my lines are crossing through the center. Because if we just do like horizontal lines and vertical, I keep doing it backwards. If we just do horizontal lines or vertical lines, our pieces are not going to be equal. But if we are going through the center of the shape, then our parts will be equal. So I'm going to just draw this out really fast just to emphasize what I'm talking about. So you can kind of get an idea of what I'm saying. Ooh, okay, my hexagon does not look great, but that's okay. So what I'm saying is that I'm not going to do a vertical line like this to divide it into 6 equal parts, because these parts on the ends are not going to be equal to the parts in the middle. And so if you just do like those straight cuts, it's not going to work out. So get rid of that terrible looking shape. So we want to focus on the center and do our partitioning through the center. So it's a hexagon. A hexagon has 6 sides. We have to divide it into 6 equal parts. And so what I can do is go through the center and just connect the center to each corner. So I'm just gonna draw lines as best I can. It's hard to draw it when I'm holding it like that. Oops. So then it looks like this. So again, we go through our center and we connect the corners to the middle, corner to middle, and now I have 6 equal parts. 1, 2, 3, 4, 5, 6. So now Rex is going to paint one of these parts green. Let's do this one. It says, what unit fraction of the pool should Rex paint? Well, he's painting one part of the 6 total parts. So our unit fraction would be 1/6. He's painting 1/6 of the pool. That's it. That's all we're doing. Pretty easy, right? Okay, next page, 394. Number 1, it says, Lef is designing an octagonal shaped rug. Okay, we're doing an octagon. He wants to divide the rug into 8 parts that each have an equal area. How can you write the area of each part as a unit fraction of the whole? So it says, how can you write how can you write the area of each part as a unit fraction of the whole? Basically, what does each part represent? Part A says, how can you show that the parts of your octagon are equal in area? So again, with octagons, hexagons, circles, like I said before, shapes that are just circular in nature, I always start in the center. I am not going to do horizontal and vertical cuts. I am going to do partitions from the center. So this is an octagon, has 8 sides. I want to divide it into 8 parts. That makes it easy. I'm just going to go from the center to the corner like I did with the hexagonal pool from the Spark Your Learning activity. So I just draw from the center. Can you see? Oh, my hand is right in the way. Sorry. So I'm starting from the center, go to the corner. Just doing the best that I can. Okay, ta-da! So now I have this octagonal shaped rug divided into 8 parts that have an equal area. How can I show that the parts of your octagon are equal in area? Well, with shapes like this, we don't have a grid paper to measure it, and even if we did, it would be hard to measure because each shape is a triangle, and so you would have a grid is made up of squares, and so you would have some squares that are cut off, and so it's just kind of hard to measure it that way, measure the area using the grid that way. But what we do for shapes like trapezoids and octagons is we could trace it, cut it out, cut each part out, lay them on top of each other, and that would show that they're all the same. Okay, I know they're all the same because I did the same thing, I did the same cut for every part. So that's what you would write there, right here. Part B says, what is the area of each equal part written as a unit fraction? Basically, what is this worth? What is each part worth? Not together, on their own. That's what a unit fraction is. On their own, what is this worth? That's good. We need to remember that. On their own, what is it worth? It is worth 1 part of the 8 total parts. So 1/8. Part C says, how can Lef divide the rug into 2 parts of equal area? Show how Lef should divide the rug on the right above. So this other octagon, I'm sure you were wondering, what is that octagon for? Now you know, it's for part C. It says divide it into 2 equal parts. 2 equal parts, I'm just going to divide it in half. I am going to divide, since this is an octagon, there are 8 sides, 8 corners. 8 divided by 2, because I'm doing halves, is 4. And so I'm going to do 1 corner and count 1, 2, 3, 4. Ooh, see what I did there? That was kind of magical. Here's 1 corner. This is an octagon. Octagons have 8 sides, 8 corners. So I'm going, if I want 2 equal parts, I'm going to cut it in half. Half of 8 is 4. So I'm counting 1, 2, 3, 4. Oh, that was magical. Okay. What unit fraction represents the area of each equal part of the whole? So again, what does each of this part represent on its own? This part represents 1/2 of the octagon. The Turn and Talk says, can you think of another way to divide the rug into 2 equal parts? Explain. There could be lots of ways to divide it in half. I would do maybe just this corner to this corner, the top to the bottom, just any way where I knew I could fold it in half and those sides would be perfectly symmetrical and they would match perfectly. So anyway, like that. All right, next page. To step it out. Are we feeling good so far? Okay, good. All right, number 2. Meg divides a circular shaped rug into equal parts. How can you write the area of each part of Meg's rug as a unit fraction? Find the denominator. How many equal parts are in the whole? So we know the denominator is the bottom number. The denominator tells us how many parts are in the whole circle. So let's just count because Meg already divided it. So we'll just count 1, 2, 3, 4, 5, 6 parts. 6 equal parts. So you can tell Meg also started in the center and then just drew 6 equal lines like we have been doing. All right, part B. Find the numerator. How many parts are being counted? That's what numerator tells us, how many parts are being counted. We want to know each part, so each one of these parts. So there is 1 part counted. So the area of each equal part of Meg's rug is 1/6. Basically what we're saying is each one of these little slices of pie represents 1/6. Okay, feeling great. Oh, let's do the turn and talk. It says Meg divides another identical rug into 4 equal parts. So another circular rug into 4 equal parts. Will each equal part be larger or smaller in area than the parts in the diagram above? Okay, this is actually really good. Okay, so I'm gonna draw a circle as best I can right underneath the circle of Meg's rug, like that. It got a little wonky, that's good. So now I'm gonna divide it into 4 equal parts. Again, I'm not gonna do horizontal lines, just like bam, 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 bam. I am dividing it into fourths, so I'm gonna do a cross, like that. So if I divide it into fourths, each fourth takes up more space than 1/6 would, because there's less pieces. Okay, this is like actually a little bit mind-blowing. Are you guys ready? The bigger the denominator, oh wait. The bigger the denominator, the smaller piece you will have. And that goes forever and always. The bigger the denominator, the smaller piece you will have. Okay? We have, because if you think about it, if you have the same object sharing the same space, if I had to split it into sixths, those pieces are going to be smaller than if I had to just split it in half. Imagine a pan of brownies, okay? I'm kind of going on a little bit of a tangent, but you guys know that that's just what Miss Lundquist does sometimes. Okay, here's my pan of brownies. I'm gonna draw it differently. Okay, hang in there. You guys are amazing. Okay, so here is a pan of brownies. I drew 2 of them so that you could see a visual representation. If I made these brownies for me and my 5 friends, that would be 6 of us sharing the pan of brownies. So I want everyone to have an equal share. So I'm going to divide this into sixths. So that everybody gets a piece of the brownie. Okay, so we're happy. We have all these brownies. My piece of the brownies is a little small, but that's okay. Everybody gets a fair amount. But if I only split the brownies with me and Mr. Fiance, I would just split the pan of brownies in half. Whoa, now all of a sudden I have a huge section of brownies. It was the same pan, I just divided it in half instead of dividing it into sixths, which is crazy. Sometimes that gets a little confusing with students. They think that, oh, since the number is bigger, the pieces must be bigger. If the denominator is bigger, that means that there are more pieces in the same shape, the same whole. So they have to be smaller to fit them all in. Okay? So there's my little tangent. Moving on. Oh my goodness. Okay, number 1 of the check understanding. Everything is okay. I just put my hand down onto the desk, and the whiteboard was on my desk, but only about halfway, so I accidentally hit the whiteboard like this, and it just went launching. So put that back there. Okay, number 1. Divide the shape into 2 equal areas. What unit fraction names each equal part of the shape? We have a triangle. Now, am I going to divide it across like this horizontally? No, because then the top part is not going to be equal to the bottom part, and that is not okay. That does not make for equal parts. So what I'm going to do is go from the corner straight down. Now I have 2 halves. What unit fraction names each equal part of the shape? Well, each part is 1 of 2. So it's 1/2. Number 2, divide the shape into 3 equal areas. What unit fraction names each equal part of the shape? So for this one, since it's 3 and it's a rectangle, I am just going to do horizontal lines. The more familiar you are with the shapes and dividing them, the better you'll be at like guessing the kind of cuts you should make. Like with circles, if it's divided into fourths, we're gonna do a cross, right? If it's a rectangle and it's divided into 6, we'll do 3 lines and 1 across the middle, right? So it's 6. If it's a square and it's 3, we're not going to do the same thing that we would do for a circle. If we divide a circle into 3 parts, we do the upside down Y thing, like that. This is not the same technique we would do for a rectangle. I guess you could, but you just usually wouldn't. This lesson is just like, okay, number 2. So we divided it into 3 equal areas. And so what unit fraction names each equal part of the shape? So each part is 1 of 3. So it's 1/3. 1 piece of 3 total pieces. Cruising. Next page, 396, on your own, it says, Ina shades 4 fraction circles. Name the unit fraction that matches the area shaded blue. So the first one is done for us. The blue part is 1/2 of the circle. Okay, to find the unit fraction for this next circle, I need to find out how many equal parts there are. There are 4 equal parts. 1 of them is blue. Each of them represent 1 of the 4 pieces. This next circle is divided into 1, 2, 3, 4, 5, 6 equal parts. So each of them represents 1/6. 1, 2, 3, 4, 5, 6, 7, 8 equal parts. 1 of them would be 1/8. Each of those parts represents 1/8. Describe a pattern you see in the fractions. What do you think? What's a pattern that you see? Well, I see that we have the number 1 staying on all of them. because they're unit fractions, so we use 1. I noticed that the size of the blue parts decreases when the denominator increases, which is what we were just talking about. So you can write that all down. All right, number 4 says, Chemo says he colored 1/6 of the square green. Is he correct? Explain. Now let's take a look at this shape that he drew. He says that he colored 1/6 of the square green. Now there are 6, 1, 2, 3, 4, 5, 6. There are 6 boxes here, but are they equal to each other? No, this one is big. These are small. Those ones are small. That one is big. So we cannot say that this is 1/6 because the parts are not equal to each other. So that's what you're gonna write down right here. All right, number 5, it says, computer engineers use real batting record data to design this computer baseball game. What fraction of the game board counts for a double? So let's see all of these options here. We've got pop out, home run, single, double, line out, ground out, fly out, and strike out. So how many options are there to land on this board game? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 options, so that's our denominator. And how many of these options are doubles? Right here. So I don't mean double like it happens twice. It's just the double, the word, which is a phrase for baseball. So that's a double right there. So there's only 1 of them on the game board, and so our fraction is 1/8. Then the next question says, which is more likely, that a player gets a home run or a strikeout? Okay, so let's find which one is more likely, a home run or a strikeout. So I need to find out the fraction that represents our chances for a home run and a fraction that represents our chances for a strikeout and see which one is greater. So for both of these options, our denominator is going to be 8 because it's the same game and there are 8 options. So now I'm going to just look at our game board and see how many times home run it appears on the game board. And it looks like I only see it 1 time. So it is 1, there's a 1 in 8 chance that we land on a home run. What about a strikeout? Let's see if we can find it. There's 1, and that's the only one I see. So there is a 1 in 8 chance that you land on a strikeout. So which is more likely, a home run or a strikeout? They're the same. The chances are the same. So that's what you would write down. The chances are the same. Ta-da! All done. All right, you'll do the learning mindset. It says, what tools can I use to check to see if I can write the area of each part of a shape as a unit fraction of a whole? So how do you know if you could even describe the part in a fraction? Well, you need to see that each part is equal to each other. So one strategy is to trace it, cut it out, line them up to each other, and see if one is greater, one is less, or if they're all the same. And that's how you could tell. But there might be other ideas too, so you write those down. All right, that was the last lesson of Module 14. We're cruising through. I hope this lesson made sense. I know I went on a couple of tangents, but I hope it was helpful, and good luck on your homework, and I'll talk to you later. Love your guts. Bye.